Okay, so today we're going to be proving statements about segments and angles. It's chapter 2, section 5. So here is our introduction to what a proof is. And a proof is a logical argument that shows a statement is true. Now there's different formats to write proofs. There's actually a flowchart proof and a paragraph proof in addition to the two-column format. However, in this class, we are only going to focus on the two-column format. I wanted you to be aware that these other two exist in case you happen to see them on a standardized test. But all of the proofs we will write will be two-column format, and we'll have a column for statements and a column for the reasons. Our statements are going to be either our given information or the result of applying a known property or a fact. And then the reasons will be the explanation for each corresponding statement. And let's go on. So acceptable reasons in a proof. Again, the first statement is always your given. I always like to put all of my given information usually in one step instead of putting, if I have 3 different pieces of given, putting 3 different statements. I like to just get all the given in one, and then the reason is given. You can also use definitions as a reason in a proof, properties, postulates, and theorems. Now, a reason in a proof, you can't write the words because I think so. It has to be facts, definitions, properties, postulates, theorems. Now, I'm going to clarify what previously proven ones mean as far as the theorems go. Now, one thing to keep in mind in this course is geometry is cumulative, meaning whatever we have learned back in August is fair game on a test for, say, chapter 10 that we might take in April. So it's not like you study for the chapter 1 test and that information magically disappears. You have to keep a running memory of all the information. The stuff that we learned in chapter 1 about vertical angles and supplementary and complementary, we're going to be using those a lot. So they don't go away. What it means here by previously proven ones is that, let's say we're writing a proof in chapter 2. The only thing that you can give me as a reason in a proof is information that we learned in chapter 1 and in chapter 2. Now, some of you may have taken geometry maybe in middle school as part of your pre-algebra, and maybe you have knowledge about a geometric figure, but we may not learn it until chapter 5. So if we're in chapter 2, you can't use information that's going to come later on in the year from, say, chapter 5 or chapter 10. So anytime we write proofs, you can only use the chapters we've already learned. So by the time we get to chapter 5 and we're writing proofs in chapter 5, you can use anything from chapters 1, 2, 3, 4, or 5. Nothing beyond that. And that's what I mean by previously proven ones. Everybody good on this slide? All right, let's see what a theorem is. So a theorem is a statement that can be proven, and we're going to prove theorems using deductive reasoning. We're introduced to our first 2 theorems, and they are the properties of segment congruence and properties of angle congruence. Now, yesterday we already saw the segment equality and the angle equality properties. These are exactly the same properties. The only difference is we're going to change the equal sign to a congruent symbol. So the next slide has the chart that you saw yesterday, but now what we're changing is, instead of properties of equality, they're properties of congruence. Now, as far as I'm concerned, you can use equality and congruence interchangeably. I'm not going to expect you to tell me it's the reflexive property of equality or the reflexive property of congruence. As long as you just write the word reflexive, if that is a reason in your proof, that's all you need to put. You don't have to specify property of equality or property of congruence. Next, that chart. So it's basically the same chart from yesterday. The only difference is they're changing the word here. So now instead of saying property of equality, they're saying property of congruence. And what they've changed is instead of an equal sign here, it's now a congruency symbol. And the difference between the equal sign and the congruence, the equal sign is actually talking about numbers. So let's say I told you the length of DE was 5. You would show 5 equals 5 if it were an equal sign. When it's the congruence symbol, all I care about is that DE is the same size as DE. I don't care if it's 5 inches long or 10 inches long. Okay, all I'm caring about is that it's the same size. So that's the difference between the equal sign and the congruency. The equal is actually talking about an exact measurement number. So these are the same properties as yesterday: reflexive, symmetric, and transitive. But now instead of an equal sign, we've got a congruent symbol. Here's our first example. It's asking us to write a 2-column proof. Now notice this time our given information isn't something that we have to pull off the diagram. It's a statement here, and it's AC equals AB plus AB. So they've already written the statements for us. All we need to do is provide the reasons now. And number 1, that is our given. Now, when you're doing this on a test or a quiz, my advice to you is, let's say you blank out and you have no clue of where to start. At least get down that given. Those are worth points by just taking the given up here and rewriting it as your first step. So then now we're going to go ahead and see if we can figure out what did they do in statement number 2. They're talking about AB plus BC, and they're telling us it equals the whole thing. So this is, again, our segment addition postulate, because they're showing that the little piece of AB plus the other little piece of BC equals the whole thing. You can either abbreviate it or you can write out segment addition postulate. Then number 3. Now that we've established what AC equals in 2 different ways, because AC is here, and they're telling us it equals A plus B, and then they give us another AC and telling us it equals AB plus BC. So now what we've done is we've done a substitution here. Now, if you flip it around, you could also say that this is transitive. So either way, I would accept either answer, substitution, or I would also accept transitive. What I like to see when it's transitive, like for example, if I rewrite it up top here, let's say I had AB, oh, that's not going to show up. Let's say I had AB plus AB equals AC, and AC equals AB plus BC. Then I can see transitive a little bit better because the ACs cancel, and then that's how they're getting to this statement, which is here. But again, either reason would be acceptable. And now, again, our goal, always refer back to what you're trying to prove. and we were trying to prove that AB equals BC. Well, notice, once we did this, they both got an AB. So if I just subtract that AB from both sides, then that gives me what I was trying to prove. So what they did from step 3 to 4 is they'd use your subtraction property of equality. And again, just putting subtraction is fine. If you want to add in POE, you can do that also. When you're writing your proof, just like with the algebra proofs, it's got to flow logically. What happens the first time students are writing proofs, they end up throwing random stuff in there that has nothing to do with what they're trying to get to. Keep in mind when you write these proofs, your steps may be longer than what I'm looking for. And for some proofs, there may be a different order. So as long as it flows logically, you could have a different answer than, say, what the textbook is expecting. So when you go to check your answers tonight, as long as it flows logically and you're using actual facts and giving the reasons as your definitions, postulates, theorems, then that's fine. So just keep that in mind. If I give you a test and I'm asking you to write a proof, and maybe I only give you 5 blank lines, but somehow you have an extra step in there, you might end up, with 6 steps instead of 5, which is fine. Generally, if we're going to still be doing Canvas tests and quizzes, I did teach geometry over the summer, last summer, and when I would give them proofs to fill in, I would give them more blanks than they really needed, just to have enough spots where people could put things in. Maybe I'll even do it as like an upload or something. We'll see when that happens. All right, let's try the next example. So again, 2-column proof. Remember, we don't write flow proofs, flow charts, or paragraphs. All of the proofs we're going to write in this course are going to be 2 columns. So we can see that our given information is that M is the midpoint of AB. And we learned about midpoint back in chapter 1. So this is given. Now, if you remember what a midpoint does from chapter 1, remember if we're told that M is the midpoint, remember that that's going to split our segment AB into 2 congruent pieces. So that's what the next statement states, is AM is congruent to MB, and this is, I can state this because it is the definition of midpoint. Now, the step from 2 to 3, you can skip this in your proof. If you would have just wanted to eliminate this step and just gone right to AM equals MB, I'm okay with that. But if you are filling in the blanks and the statements are already given to you, what they did from 2 to 3 is they changed the congruent symbol to an equal sign, and this reason is definition of congruent segments. So if you were writing your own proof, you could have skipped step 2 and gone right into step 3. I would have been okay with that. Now what they're doing in step 4, they're trying to bring in the information about AB. And notice they're showing us that AM plus MB equals the whole thing, and this is our segment addition postulate. Now, in step 5, what they've done is they've taken out MB and they've replaced it with what MB equals, which is AM. And this is a substitution. I couldn't do a transitive here. And now in step 6, what they did was they combined like terms, so they simplified. We added 1 AM plus 1 AM and got 2 AM. And now to go from step 6 to step 7, they've divided both sides by 2. So this is the division property. And it's the property of equality, but you don't need to put that. Now, if you would have told me multiplication, because it's like multiply by the reciprocal, I would accept multiplication also. Because you could have said, I'm multiplying both sides by 1/2. So if you said multiplication here, I would also accept that. So your next slide, this is just a little overview of writing a 2-column proof. Remember, when you write it, you're going to make one statement at a time to try to get to your conclusion or what you're trying to prove. Again, your statement should be based on facts, and you're using deductive reasoning. And then each statement should have a reason. If you're not given a diagram, you might want to draw one for yourself just to give yourself a visual. Generally, your given information is going to be written out in words or symbols. Sometimes it's only a diagram, and if that's the case, you would pull off what you see in the diagram. And then this is the statement you're trying to prove. Remember that I would always, don't leave anything behind, always put the given as step number 1. Then what you're trying to prove is always going to be the last statement. Again, you get points just for putting that in there. Whether or not you come up with the right reason, that remains to be seen. Now, the number of statements that you come up with could be different from everybody. It all depends on if you give extra steps that maybe weren't necessary to get to what you're trying to prove. So sometimes some students at the beginning will take a lot longer. Generally, our proofs aren't very long, maybe 7, 8 steps at the most, but most of them are going to be pretty short like this. Maybe 4 statements, 5 statements, not very long. So that is it. This is your introduction to proofs, geometry. Your homework tonight is not very long. You do have to attempt to write some of these proofs. I do not want to see them left blank. I want to see an honest attempt on these proofs. I do completely understand that they are going to be challenging at first, but give it your best shot.